Hello friends. So we have a question on functions chapter. We are given a function fx is equals to root under x square minus 1, and it is also given that the value of x varies from 1 to 2. Now we have to sketch the curve of this fx, and at the same time we have to also identify the inverse function and its domain. So let us try to find the curve of this function fx. Now fx is equals to root under x square minus 1, and x is ranging from 1 to 2. So if we try to draw the graph, we know what we need to know is first the intersection with x and y axis. Then we would like to know whether this curve is increasing or decreasing. So let us also try to find the first derivative. First derivative will be 1 by 2 root under x square minus 1 into 2x. So this will be x divided by root under x square minus 1, and we know between 1 and 2 this will be positive. So the curve have an increasing graph between 1 and 2. Now let us try to find the second derivative. Second derivative would be root under x square minus 1. Applying the differentiation rule, and the second term would be 2x divided by root under x square minus 1 divided by x square minus 1. So further simplifying this, we will get x square minus 1 minus x square, there will be 2 also, x square divided by x square minus 1 into root under x square minus 1. So if this will be cancelled and this will be negative, that means the graph will be concave down. As the second derivative is less than 0, the graph will be concave down. Now at x equals to 1, the graph has a value of 0. So at x equals to 1, the graph is 0. So this point is there. Then at x equals to 2, the value of the graph is root 3. So this point is 2 comma root 3, and this point is 1 comma 0. We have to draw the graph between 1 and 2 only. Now from this point to here, the graph has an increasing graph because f dash x is positive, and at the same time, since double derivative is negative, the second derivative is negative, it is concave down. So the graph would be something like this. So this will be the graph between 1 and 2. Now let us move on to the next part. In the next part, we have to identify the inverse of this given function. Now fx is given to us root under x square minus 1, and in this root under x square minus 1, we know x is varying between 1 and 2, and as you can see in the graph, y varies between 0 and root 3. Now to get the inverse, we will replace this is our y with x and x with y. So it will be x is equals to root under y square minus 1. Now y will be varying between 2 and 1, and x would be varying from 0 to root 3. Between 0 and root 3. Now let's try to find the y in terms of x, is which y square minus 1 equals to x square. Y square will be x square plus 1. So y will be plus minus root under x square plus 1. Now we already know y is varying between 1 and 2, and x is varying from 0 to root 3. Now since y is always positive between 1 and 2, we reject the negative part. So y will only be equals to x square plus 1 as given in the function. Now the second part we have already solved it, because this is our range and this is our domain. The range and domain of fx will be reversed. So our range in this case for the f inverse will be between 1 and 2, and the domain will be between 0 and root 3. So now let us move on to the next part. In the next part, it is given that the curve y equals to fx, this curve which we have drew, is rotated 2 pi about the y-axis. Now it is rotated 2 pi about the y-axis. That means it is rotated something like this. So you will be getting a shape which is like a container. So you get a container after rotating the graph by 2 pi about the y-axis. Now in the first part we have to show that the volume V of the water in the container is filled to a height h is given by an expression. So let us try to solve this part. The container is something like this and we have to find the volume, and these are your axes. Now let us try to understand how to find the volume of this container with using integration. So let us take a small cylinder here having a height of dh, the radius will be x. So the volume of this cylinder would be area of base into height. The area of base is pi x square into height, the small volume of this cylinder. Now we can integrate this from 0 to v and it from 0 to h to get a volume at a particular height. 0 to h. Now the dh is basically in the y direction and x is basically y is equals to root under x square minus 1. So x can be written as square plus 1. So we can write this expression as an integration of pi into 0 to say up to h pi y square. In place of x we can write pi y square plus 1 x in place of x square, and dh is basically dy. The height is in the y direction. Now integrating this we get pi into this pi is repeated 0 to h y square plus 1 into dy. So this will be pi into y cube by 3 plus y 0 to h. So putting the value of h here we get pi into h cube by 3 plus h. So we get the volume in terms of h as pi into h cube by 3 plus h. So this is the volume at a particular h, and h is varying from 0 to the maximum value y can attain, which in this case is root 3. So in the second part of this particular section we need to find the maximum volume of the container, and we know the maximum h can vary from is h is less than equals to root 3 and greater than equals to 0. So h can maximum be root 3. So maximum volume will be when h is equals to root 3. So the volume will be pi into root 3 cube divided by 3 plus root 3. Solving this we will get 10.88, or this can be written as 10.9 meter cube. So this is your answer. So in the D part we have to find the time it will take to fill the container if the water is coming at a rate of 0.4 meter cube per second, and we also have to find the rate of change of height when the volume is half filled. So the time it will take will be equals to the V max divided by the rate at which the water is coming in, which is 0.4. The volume has been identified in the previous part as 10.9. This is the maximum volume divided by 0.4. So we would be getting is 27.2 seconds. Now let us move on to the next part. In the next part we have to find the rate of change of height when the volume is half filled. Now the volume is approximately 10.9, so V by 2 will be equal to 5.45. So at this volume we have to find, so the volume is has been identified in the previous part is pi into plus h. Now we can simplify this dv by dt, this divide differentiating and dividing by with respect to time, we get pi into h square plus 1 into dh by dt. So we can identify dh by dt is equals to dv by dt into 1 by pi into h square plus 1. So dv by dt is 0.4 divided by pi into h square plus 1. So we also need to know the value of h. So can we find this? Yes. We have identified volume in terms of h, that is h cube by 3 plus h, and we know the volume of V is 0.5.45, so this will be equals to pi into h cube by 3 plus h. So this is a cubic in h, and we can solve this and we can find the value of h as 1.18. The height at which the volume is half filled is 1.18. Putting this value in this expression, 4 divided by 1.18 square plus 1. You can further simplify it to get 0.05 meter per second. So this is the height at which the volume will be filling in the container when it is half filled. Thank you. And for more such questions and explanations, do visit our website IIN Academy and register